Hello everyone, myself from Dr. Lakshmi Soujanya. I'm working as an associate professor in the Department of Mathematics, Marri Reddy Institute of Technology and Management. In the previous lecture, we just discussed about the basics of matrices and what are the basics we required to learn about the topics in the matrices. Today, we are going to discuss about the echelon form, which is used to find the rank of a matrix. Echelon form or row echelon form, both are same. Why we are using row echelon form means here we have to apply row operations only to convert the matrix to echelon form. So it's a special type of matrix. Echelon form means if we are expressing the matrix if we have any matrix, echelon form means if any matrix satisfies three conditions, then we can say that such matrix as echelon form. The three conditions are, your first condition is if there is any zero row in the matrix, the row must and should be at the bottom of the matrix. It occupies the last row of the matrix. The second condition, the number of non-zeros before the first non-zero entity in a non-zero row is must and should be less than such zeros in the next row. That is the second condition. And your third condition is the non-zero entity before the first non-zero value in a non-zero row is must and should be 1. So we are having three conditions. First one is if there is any zero row, the zero row must and should be at the bottom of the matrix. Second one, the number of zeros before the first non-zero entity in a non-zero row is must and should be less than such zeros in the next row. And third one is the non-zero value before the first non-zero value in a non-zero row is must and should be 1. These are three conditions. For suppose if I am taking an upper triangular matrix, so I am choosing one upper triangular matrix like some 1, 2, 3, 0, 1, 2, 0, 0, 1. I have taken some 3 by 3 upper triangular matrix. All the lower diagonal values are 0 in this case. Now you compare this matrix with the conditions of echelon form. Your first condition is if there is any zero row, the zero row must and should be at the bottom of the matrix. Zero row means all the entities in the row is must and should be 0. Here I don't have any such zero, so there is no condition there, so no need to verify the first condition. For suppose if you are having 0, like if your matrix is the same upper triangular matrix, I'll take like this 1, 0, 2, 3, 4, 0, 1, 2, 3, 0, 0, 1, 2, 0, 0, 0, 0. I have chosen some 4 by 4 matrix. In this matrix, this is also an upper triangular matrix. All the lower diagonal values are 0 here. So, here if you are comparing the echelon form first condition, the 0 row must and should be at the bottom of matrix. Here I have one 0 row and clearly it is at the bottom of the matrix. In this example, I don't have any 0 row, so you can neglect that condition. Next, second condition, the number of zeros before the first non-zero value in a non-zero row is must and should be less than such zeros in the next row. For suppose if I am taking second row, in the second row, the number of zeros before the first non-zero value in a non-zero row. Second one is a non-zero row, your second row is a non-zero row. And before the first non-zero value, this is a non-zero value. So before this non-zero value, I have only 1 0, number of zeros. Next, in the next row, which is less than such zeros in the next row. So in the next row, this is our first non-zero entity. Before this one non-zero entity, here I have 2 zeros. So clearly 1 is less than 2. Similarly, if you are taking this example, in this example, there is no zero value in the first row. If you are taking second row, in the second row, the first non-zero value is 1 and number of zeros before 1 is 1. In the next row, third row, the non-zero value, first non-zero value is 1. Before that, the number of zeros are 2. In the third row, totally we are having all our zeros only. So it's a 0 row. So here the number of zeros are 4. So totally 1 less than 2 less than 4. So this is also satisfying the condition. And next, third condition, the first non-zero value in a non-zero row is must and should be 1. Your first row is a non-zero row and first non-zero value is 1. Your second row is also a non-zero row. Here also the first non-zero value is 1. Your third row is a non-zero row. The first non-zero value is 1. So if any matrix satisfies these three conditions, then such matrix is called as echelon form. As I said, we can use echelon form to find the rank of matrix. So the rank of matrix is defined basing on the number of non-zero rows in the echelon form. That means the echelon form has 3 non-zero rows, then the rank is 3. If it has 2 non-zero rows in the echelon form, then the rank is 2. So here in the first example, I have 3 non-zero rows. So for this case, so here the first example, I have 3 non-zero rows. So in this case, the rank value is equal to 3. In the next example, here also I have 3 non-zero rows. The fourth row is a 0 row. So here the rank is equal to 3 only. So this is the echelon form. Echelon form means it has to satisfy 3 conditions. If there is any 0 row must and should be at the bottom of the matrix. The number of zeros before the non-zero entity in a non-zero row is must and should be less than such zeros in the next row. And third condition is the first non-zero entity in a non-zero row is must and should be 1. So if any matrix satisfies these 3 conditions, then the number of non-zero rows in the echelon form is chosen as the rank of the given matrix. So here, as I said, upper triangular matrix clearly satisfying all the 3 conditions of echelon form. So if you want to convert the matrix to echelon form, your aim is you have to convert the matrix to upper triangular form. That means you have to convert all the lower diagonal values are equal to 0. Once you got the upper triangular form, then easily you can convert, you will get echelon form, then you can define the rank value. So let us see some problems on this echelon form. So here I am taking the first problem as determine the rank of the matrix. There is a 4 by 4 matrix using echelon form. So what is your aim? You have to convert the given matrix to upper triangular form. So your given matrix is So the given matrix is a 4 by 4 matrix. So here you have to convert the matrix to upper triangular form means you have to convert all the lower diagonal values to 0. Diagonal values are 1, 1, 1, 1. So lower diagonal, below diagonal values means you have to convert these values to 0. In the previous lecture, we discussed some elementary row and column operations, how we can take row and column operations. We are having 3 types of row operations. Either you can interchange 2 rows, or you can multiply any row with a non-zero scalar, or you can divide any row with a non-zero scalar. And third row operation is you can multiply any row with a non-zero scalar and add and subtract that row with the corresponding element in the other row. These are the 3 row operations or column operations. So here, since in echelon form, you have to use only row operations. By using these 3 row operations only, you have to convert this matrix to upper triangular form. So first, one by one, you can convert the value to 0. Like first, you can convert 4 to 0. Then you can go 3. Then you can convert 1. Like one by one, you can convert the values to 0. But the matrix lengthy, whenever the size of matrix becomes lengthy, the solution is also becomes very lengthy. So the simplest method to convert the values to 0, lower triangular or upper triangular, you go with column or row wise. Since I am applying only row operations, column wise you convert the values to 0. That means in the first step, I'll try to convert at a time, I'll try to convert the values which are in the first column. 4, 3, 1. I'll try to convert these 3 values to 0. Here, when you are representing the row operations, I'll represent each and every row as Ri. That means your first row is R1. I'll represent this one as R1. Next R2. Third row is R3. Fourth row is R4. So in the next step, in the first step, what we have to do? We have to convert the values which are in the first column to 0. That means which rows you have to change here? I have to convert 4, 3, 1 to 0. So I have to change R2, R3, R4. So here the row operations are for R2, R3, R4. How we can convert these values to 0? That is a main thing. If you understand this step, then easily you can convert the values in the matrix. The main thing you have to know how to convert the rows to 0. How to convert a particular value in a row to 0. So to convert this 4 value in R2, first I will see R2 value. I need to convert that 4 value to 0. So to convert that 4 value to 0, either you can use R1 or R3 or R4. But in this step, since we are changing R3 and R4 also, don't use R3 to change R3 and R4 to change R2. Since we are changing R3, R4 in the same step itself. So don't use those 2 rows to change R2. So the remaining row we are having is only R1. So in R2 and R1, I have 4 values in each and every row. You just focus on the value which you have to convert to 0. You forgot about the remaining 3 values. Your focus is on the value which you have to convert to 0. So in R2, I have to convert 4 to 0. So you choose the corresponding value which is existing in the row 1. We have to use row 1 only to change R2. Here we have to use row 1 only. So here you focus on the value which is existing in row 1. In row 1, I have 1. In row 2, I have 4. Here also, in R1 also, if you got 4, then 4 minus 4, you will get 0. That means what we have to do, you have to multiply the total row R1 with 4 and subtract that row with R2. That means here the row operation for R2 is multiply R1 with 4 minus R2, subtract from R2. Now you write down the row operation for R3. What is R3? In R3, I need to convert this 3 value to 0. Again, using R1 only, you can change R3. Why? Because we are changing R2 and R4 in the same step itself. So you can't use R3, R4. You have to use R1 only. So the corresponding value in R1 is again 1 only. So here I have 3. Here I have 1. In R1, if you got 3 value, then 3 minus 3 again you will get 0. That means the row operation is I have to multiply the first row with 3 and subtract from the third row. That means 3R1 minus R3. Next, now see R4, we have to change this 1 value to 0. Now, you can see the corresponding value in R1. The corresponding value in R1 is 1. Both are 1. So, by subtracting both the rows, you will get that value to 0. That means R4 minus R1. See, if you understand how I am taking these steps, then easily you can convert the matrix to upper triangular or lower triangular. To convert a matrix to special form, you have to know how I am taking these row operations, how I am writing the row operations like Ri value to something. You have to understand that row operations. Even though I am having set of values in the matrix, I focus on the value which you have to convert to 0 and the value, the corresponding value which row we are using. You have to focus on those 2 things only. Basing on those 2 values only, you have to write down the row operation. Now apply the row operation. So in this step, we are not changing first row. So first write down the first row. Your first row is 1, 2, minus 1, 3. Now how we are changing R2? What is the row operation we are taking here? R2 gives rise to 4R1 minus R2. So on your rough work, until you will get practice, on rough work, you just write down the row calculations, then write down the final matrix. First 4R1, multiply the first row with 4. Your first row is 1, 2, minus 1, 3. Multiply this row with 4, then you will get 4, 8, minus 4, 12. And next R2, your R2 is 4, 1, 2, 1. By subtracting both the rows, you will get the required row. So what is the required row? 4 minus 4, 0, 8 minus 1, 7, minus 4 minus 2, minus 6, 12 minus 1, 11. Next, what is the row operation we are taking for R3? 3R1 minus R3. So first multiply the first row with 3. So I am multiplying the first row values 3. 3 ones are 3. 3 twos are 6. 3 again 3 into minus 1 minus 3. 3 threes are 9. Next R3. R3 is 3 minus 1, 1, 2. By subtracting you will get 3 minus 3, 0. 6 minus of minus 1 plus 1, so that is 7. Minus 3 minus 1 is minus 4. 9 minus 2 is again 7. Next R4. R4 is R4 minus R1. We are changing R4 by using the row operation. R4 minus R1. So what is R4? R4 is 1, 2, 0, 1. R1 is 1, 2, minus 1, 3. By subtracting you will get 0. 2 minus 2 again 0. 0 minus of minus 1 plus 1. 1 minus 3 is minus 2. So this is a converted matrix. Again, you represent the lower diagonal values. These are your lower diagonal values. Now see, at a time, in a single step, we converted all the first column values to 0. So now, in the next step, you go to the second column. In second column, I have two values to convert to 0. Since already one value is 0, I'll focus on this 7 only. I'll convert only 7 value to 0. That means which row we have to change here? This is in third row. So we have to take, in the next step, we have to take row operation for R3. Now, which row we can use to convert R3 to 0? We are not changing R1, R2, R4. So, out of these 3, we can use any one of the row. But see, here to change R3, if we are using R1, the corresponding value in R1 is 2. There is no common multiple. You can do cross multiplication and you can convert the value to 0. That means here you can multiply with 7, you will get 14. Here you can multiply with 2, you will get 14. 14 minus 14, you will get 0. But when you are doing the row operation, here I have non-zero value. If you multiply this value with 7 and subtract it with this value, again this 0 value converts to non-zero value. So when you are converting the row operation, you are taking row operations from second step onwards, you choose the rows which are similar to your changing row. Then only these 0 values are not converted to non-zero values. Again, if these are converted to non-zero, again you have to do another row operation. So the solution becomes lengthy. So here you remember one point. From second step onwards, when you want to change any row, you consider the rows which are similar to that form. Similar to that form means, here see the first value is 0. In the third row, the first value is 0. In the second row, similarly in fourth row also the first value is 0. So either you can use R2 or you can use R4. If I am taking R4, since this value is 0, the corresponding value for R3 in R4 is 0, you can't convert R3 value to 0. So you can't use R4 also. So the only possibility you are having to change R3 value to 0 is R2. Using R2 only, you can change the value to 0. So the corresponding value in R2 is 7. Now by subtracting both the values, you will get 0. 7 minus 7, you will get 0. That means the row operation is, you have to subtract R3 from R2 or R2 from R3. So R3 gives rise to R3 minus R2. Then what about your new matrix? In this step, we are not changing first row, second row and fourth row. So first you write down the non-zero rows which are not changed. So that those are 1, 2, minus 1, 3. We are not changing second row also, 0, 7, minus 6, 11. And we are not changing fourth row also. So first take the row operation for R3. R3 row operation is 0, 0, 2, minus 4. Now first write down the rows which are not changing. The non-changed rows are first, second, third. So 1, 2, minus 1, 3. 0, 7, minus 6, 11. Next 0, 0, 2, minus 4. Now by subtracting these two rows, both are same values. So by subtracting, you will get zeros. All are zeros. Okay, so now we got the upper triangular matrix. Here all the lower diagonal values are converted to 0. So we got upper triangular. Now compare with echelon form. What is the first condition in echelon form? If there is any 0 row, the 0 row must and should be at the bottom of the matrix. See, I have one 0 row. The last row entities all are 0. So it is a 0 row. Clearly it is at bottom of the matrix only. It's satisfying the first condition. Next, second condition, the number of zeros before the non-zero row is less than the number of such zeros in the next row. So here the number of zeros are 1. Here number of zeros are 2. And here the number of zeros are 4. Clearly 1 less than, 2 less than 4. It's satisfying the second condition also. And third condition, the non-zero value, the first non-zero value in a non-zero row is must and should be 1. The first non-zero value in a non-zero row is 1. And here I have 7, here I have 2. In these two places, if you got 1, then you will get echelon form. So how you can get 1? We can use another row operation, that is either you can multiply or divide any row with a non-zero scalar. So I can divide the second row with 7 and I can divide the third row with 2. What is the excess term we are having in that particular place? You divide the entire row with that value. So that means your next row operation is divide the second row with 7 and the third row with 2. So now your matrix is, we are not changing first row, 1, 2 minus 1, 3, and divide the second row with 7. So this is 0, 1, minus 6 by 7, 11 by 7. Next divide the third row with 2, 0, 0, 1, minus 2, and last row is 0, 0. So now clearly this value, this matrix is in echelon form. Now what is the rank of the matrix? The number of non-zero rows in echelon form is your rank. How many non-zero rows I have here? First row is non-zero, second row is non-zero, third row is also non-zero. So totally I have 3 non-zero rows. That means the rank of this matrix is 3. So rank of the matrix A is equal to, since I have 3 non-zero rows, which is equal to 3. This is our final answer. So what we have done here, first we focus on the upper triangular matrix. Column wise, you converted each and every value to 0. Then easily you can complete the solution in 2 to 3 steps. If your matrix contains 3 rows, you can complete the solution in 2 steps. Maximum steps is 2 steps only. If matrix number of rows in your matrix are 4, then you can complete the solution. Maximum number of steps for complete the solution is 3 only. When you are doing like this, easily you can convert the matrix to upper triangular, or by using column operations, you can convert the matrix to lower triangular. So first we converted the matrix to upper triangular form. Then I compared the conditions with that upper triangular form. If I have any first non-zero entity as not 1, then divide the entire row with that value. Then you will get the echelon form. Now we can choose the rank as the number of non-zero rows in the echelon form. Let us see second problem. We'll see another problem. So the next problem is reduce the matrix. Here also I have taken some 4 by 4 matrix. You have to reduce this matrix to echelon form, and you have to find the rank also. So echelon form means first your aim is you have to convert the matrix to upper triangular. So the given matrix is 3, 1, 4, 6, 2, 1, 2, 4, 4, 2, 5, 8, 1, 1, 2, 2. So you have to convert this matrix to upper triangular, means first to represent all the lower diagonal values. What are your lower diagonal values? The diagonal values are 3, 1, 5, 2. So below the diagonal values means 2, 4, 1, 2, 1 and 2. You have to convert these values to 0. Again, since it is a 4 by 4 matrix, I'll try to complete the solution in 3 steps. Column wise, I'll convert the values to 0. That means in the first step, you focus on the values which are in the first column. At a time, you have to convert this 2, 4, 1 to 0. That means which rows we are changing? Second row, third row and fourth row. So the row operations are for R2, R3 and R4. How we can write the row operations? What is your aim? You have to focus on the value which you have to convert to 0, and the value which you have to use. You have to focus on those two only. Since at a time I am changing R2, R3, R4, to change these rows, the only possibility we are having is R1. By using R1 only, you can change R2, R3 and R4. Now see, first I'll see second row first value 2. To convert this 2 value to 0, the corresponding value in the first row is 3. So how you can get same value? Then only if you get same value in both the positions, then only you will get 0. So how you can get the same value? Previous problem, in the previous case, we got a common multiple. We have a common multiple. So we multiplied that with the corresponding value. Then we got 0. But here we are not having common multiple. Whenever you are not having common multiple, you just do cross multiplication. Multiply this value with the above row and multiply that value with the below row. That means I'll multiply the first row with 2 and I'll multiply the second row with 3. So what is the row operation? You have to multiply the first row with 2. That means 2 R1 and second row with 3. 3 R2. Then you will get 6 in both the places. Now by subtracting, you will get 0. So this is the first row operation. Next, for R3. See, now for R3, we have to convert 4 to 0 and the corresponding value in R1 is 3. Again, there is no common multiple. So, do the cross multiplication. Multiply the third row with 3 and first row with 4. So, multiply the first row with 4 and the third row with 3. So, 3 R3. Then by subtracting, you will get the same value. Next, in R4, here I have one corresponding value in first row is 3. If you got 3 here, then 3 minus 3, you will get 0. That means you have to multiply the total fourth row with 3 and subtract from R1. So, 3 R4 minus R1. These are your row operations. Now, write down the matrix. We are not changing first row. Your first row is 3, 1, 4, 6. Next, how you are changing second row? What is the operation we are taking here? 2R1 minus 3R2. First, write down 2R1. Multiply the total row with first row with 2. So, 2R1 means 2 3s are 6. 2 1s are 2, 2 4s are 8, 2 6s are 12. This total first row I am multiplying with 2. Next, 3R2. Multiply the second row with 3. 3 2s are 6, 3 1s are 3, again 3 2s are 6, 3 4s are 12. Now by subtracting 6 minus 6, you will get 0. 2 minus 3, minus 1, 8 minus 6, 2, 12 minus 12, again 0. Next, 4R1 minus 3R3. Now you multiply the first row with 4. 4 3s are 12, 4 1s are 4, 4 4s are 16, 4 6s are 24 and 3R3. Multiply the third row with 3. Then 3 4s are 12, 3 2s are 6, 3 5s are 15, 3 8s are 24. Again by subtracting 12 minus 12, 0, 4 minus 6, minus 2, 16 minus 15, 1, 24 minus 24 is 0. Next row operation is 3R4 minus R1. 3R4. So, multiply the third row with 3. 3, 3, 6, 6 minus R1. Your first row is 3, 1, 4, 6. So, by subtracting 3 minus 3 is 0. Again 3 minus 1, 2. 6 minus 4 is 2. 6 minus 6 is 0. So, now if you are taking lower diagonal values, the values which are in the first column all are converted to 0. Now, in the next step, you have to convert the values which are in the second column. So, that means you have to convert minus 2 and 2 to 0. So, which rows we have to change? R3, R4. So, your next row operations are for R3, R4. How we can change R3? By using which row we can change R3, R4? Either you can go with R1 or R2. But here from second step onwards, you have to remember one point. The row which is similar to your changing row, you use that only. So for R3 and R4, the similar row is R2 only. So by using R2 only, you can change the values of R3, R4. So the corresponding value in R2 is minus 1 and in R3 here I have minus 2. Here if you are having minus 2, if you are multiplying this row with 2, you will get minus 2. By subtracting both the rows, clearly you will get 0. That means what is the row operation? You have to multiply this entire second row with 2. So 2 R2 and subtract from R3 minus R3. Next R4. In R4 I have 2. Here I have minus 1. Here if you get 2, minus 2 plus 2, both will be 0. That means you have to multiply the second row with 2 and you have to add that row with R4. Since both are in opposite signs, here I am adding both the rows. Now what about the value? We are not changing first two rows, that is 3, 1, 4, 6, 0, minus 1, 2, 0. Next for R3, we are using the row operation as 2R2. So multiply the second row with 2. Now you have to multiply the second row with 2, that is 0, minus 2, 4, 0. And next R3. R3 is 0, minus 2, 1, 0. So by subtracting 0 minus 0, 0. Minus 2, minus of minus is plus 2. So minus 2 plus 2 is 0. 4 minus 1, 3. 0 minus 0 is again 0. Next 2R2. Multiply the second row with again 2. So if you are multiplying the second row with 2, you will get 0, minus 2, 4, 0. And R4, your R4 is 0, 2, 2, 0. By adding both the rows, now you will get 0. Minus 2 plus 2 is again 0. 4 plus 2 is 6. 0 plus 0, 0. Now if you are taking lower diagonal values, so we are having one more value that is in the third column. You have to convert this value to 0. So which row we have to change in the next step? We have to change R4. So here you have to change, in the next step, you have to change R4 value. By using which row we can change? The row similar to R4 is R3 only. So using R3 only, you can change this value. So in R3, the corresponding value is 3. Here I have 6. If you are multiplying R3 with 2, then 6 minus 6, you will get 0. That means your row operation is multiply the third row with 2 and subtract from fourth row. So we are not changing first 3 rows. First to write down the first 3 rows. Those are 3, 1, 4, 6, 0, minus 1, 2, 0, 0, 0, 3, 0. Now you have to change the fourth row by using the row operation 2R3. 2R3 means multiply the third row with 2. You will get 0, 0, 6, 0. And R4 is 0, 0, 6, 0. By subtracting, you will get 0, 0, 0, 0. Now represent the lower diagonal values. So all the lower diagonal values are converted to 0. So we got upper triangular matrix. Now you compare the conditions of echelon form. First condition, 0 row at the bottom of the matrix. Here I have one 0 row and clearly it is at the bottom of the matrix. Second condition, the number of zeros before the non-zero value are must and should be in increasing order. I have 1 0. In this row I have 2 0. Here I have 4 zeros. Those are in increasing order only. It satisfies the second condition also. Third condition, first non-zero entity is 1. Here I have 3. Here I have minus 1. Here I have 3. In all the 3 non-zero rows, we need the first non-zero value as 1. So what we have to do, you have to divide the row with the corresponding value. So that means your next row operation is divide the first row with 3. R1 gives rise to R1 by 3. And R2, I have minus 1. Here to get plus 1, you have to multiply the second row with minus sign. Next R3, in R3 here the excess term is 3. So divide the third row with 3, R3 by 3. So now what is our matrix? So your matrix is R1 gives rise to R1 by 3 means that is 1, 1 by 3, 4 by 3, 6 by 3 is 2. Next multiply the second row with minus sign 0, 1, minus 2, 0. Next divide the third row with 3. That means here you will get 0, 0, 1, 0 and fourth row is 0 row. So clearly it's satisfying all the conditions of echelon form. Therefore the rank of A is equal to the number of non-zero rows in the echelon form. How many non-zero rows I have here? First row non-zero row, second row non-zero row, and third row is also non-zero row. So totally I have 3 non-zero rows. So rank of A is equal to 3. So I hope it is clear for you how you have to convert the matrix to echelon form. Directly they'll give some matrix and they may ask to convert the matrix to echelon form and they may ask to find the rank value. And there is another possibility of question also. See the next question. In the next question, they're asking to find some unknown value if the rank of the particular matrix is so-and-so. So in that case also, you have to apply the same logic, convert the matrix to upper triangular. Here my third question is find the value of K if the rank of this matrix, 4 by 4 matrix is 2. Using this condition, rank of this 4 by 4 matrix is 2, you have to evaluate the value of K. So first, to take the rank of the particular matrix, you need upper triangular form for echelon form. So I'll convert the given matrix to upper triangular form. Then you focus on the given conditions. So your matrix is 0, 1, minus 3, minus 1, 1, 0, 1, 1, 3, 1, 0, 2, 1, 1, k, 0. So this is our matrix. Now represent the values too. First represent the lower diagonal values. These are your lower diagonal values. You have to convert these values to 0. But see here, in the first step, when like what we have done in previous cases, if you are following the same thing, first you have to convert the values in the first column. But the corresponding value in the first row is 0. If it is 0, we can't convert the remaining values to 0. Why? Because we can't take any cross multiplication or we can't take any subtraction or addition. By subtracting or addition, we can't get the value to 0. So it is not possible. In such cases, first you interchange two rows. You need to get a non-zero value in this position. So by interchanging rows, you will get that value. So what I'll do is, first I'll interchange R1 and R2. That means your row operation is interchange both R1 and R2. So your value is, instead of R2, you have to write down R1. In place of R1, you have to write down R2. So in place of R1, I am taking R2, 1, 0, 1, 1. Next, this one is R1 is 0, 1, minus 3, minus 1. I just changed the places of two rows. And remaining rows are as it is 3, 1, 0, 2, 1, 1, k, 0. So now again represent the lower diagonal values. These are your lower diagonal values. So first you focus on the values which are in the first column. You have to convert these three values to 0. Since one of the value is already 0, I'll leave that value. I'll convert the remaining values 3 and 1 to 0. That means we have to change R3 and R4. How we can change R3? The corresponding value in R1 is 1. Here I have 3. If you get 3 here, then 3 minus 3 you will get 0. That means you have to multiply the first row with 3. So first row with 3 minus third row. Subtract that row with third row. Next in R4 I have 1. Here also I have 1. So by subtracting both the rows directly you will get 0. That means R4 minus R1. Now what about these values? First row is 1, 0, 1, 1. We are not changing second row also. Next 3R1. Multiply the first row 3R1. Multiply the first row with 3. That is 3, 0, 3, 3 minus R3. R3 is 3, 1, 0, 2. So by subtracting 3 minus 3 means 0. 0 minus 1 is minus 1. 3 minus 0 is 3. 3 minus 2 is 1. Next, R4 minus R1. Subtract R4 and R1. R4 is 1, 1, k, 0. R1 is 1, 0, 1, 1. By subtracting 1 minus 1, 0. 1 minus 0, 1. K minus 1 is k minus 1. 0 minus 1 is minus 1. Again, you represent the lower diagonal values. So, first column values are converted to 0. Now you convert the values which are in the second column. That means what we have to do, your next row operation is, we have to change R3 and R4. Again, I am taking row operations for R3 and R4. By using which rows we can change these values? The similar row for R3 and R4 is R2. So using R2 only you can change R3, R4. In R2, here I have 1. By adding these two values, clearly 1 minus 1 you will get 0. That means the row operation for R3 is R2 plus R3. Next for R4, here I have 1, here I have 1. By subtracting you will get the value as 0. That means R2 minus R4. So now what about your new matrix? We are not changing first two rows, 1, 0, 1, 1, 0, 1, minus 3, minus 1. Next R2 plus R3. R2 is 0, 1, minus 3, minus 1. R3 is 0, minus 1, 3, 1. By adding both the rows, you will get 0, 1 minus 1, 0. Minus 3 plus 3 is again 0. Minus 1 plus 1 is also 0. Next, for R4, the row operation is R2 minus R4. So now what is R2 minus R4? R2 is, second row is 0, 1, minus 3, minus 1. R4 is 0, 1, k minus 1, minus 1. So by subtracting, this is 0, 1 minus 1, 0, minus 3, minus of k minus 1, minus 1, minus of minus 1 plus 1. So that is also 0. That means you will get 1, 0, 1, 1, 0, 1, minus 3, minus 1, 0, 0, 0, 0, 0, 0, minus 3, minus k plus 1. That is minus k, minus 2, 0. Okay. Now, we got, still we have one more value. We have to convert minus of k minus 2 to 0 to get upper triangular. So, what I will do is, since the corresponding value in third row is 0, here again I will interchange two rows. That means interchange R3 and R4. Then you will get 1, 0, 1, 1, 0, 1, minus 3, minus 1. Now in place of R3, you have to take R4. R4 is minus k minus 2, 0, and R3 is 0 row. Now see, we got a upper triangular matrix. All the lower diagonal values are converted to 0. Now you compare with echelon form. What we have to do in echelon form? The 0 rows must and should be at the bottom of matrix. Number of zeros are in increasing order. First non-zero entities must and should be 1. Here, since I need to calculate this k value, I'll neglect that condition. First non-zero is first and should be 1. I'll neglect that condition. Now you see the given rank. What is the given rank? Rank of A is equal to 2. Using echelon form, we can take the rank as the number of non-zero rows in echelon form. So if your above matrix is in echelon form, then we need only 2 non-zero rows. But how many non-zero rows I have here? First row, second row. In third row also, due to this minus k minus 2, I got 3. I'm getting 3 non-zero rows. But we need only 2 non-zero rows. So what we have to do? If this minus k minus 2 is equal to 0, then definitely you will get 2 non-zero rows. If the given condition is satisfied, that means the rank of A equal to 2 is possible if minus k minus 2 equal to 0. So the value of k is minus 2. So using echelon form, you can solve unknown parameters like this also. So this is another model of this problem. So with this, I'll complete the echelon form. I explained 2 problems and third one is a different model problem. In the next session, we'll go with the next concept, canonical or normal form. Thank you.